So now my circle, the cross section of the pin is getting load like this. We are saying that the equivalent of this load is P. P by A is my cross sectional area. Clear or not? So all of this is actually simplified as some force like this, which is equal to P. So P by A. This is I mean, there are many problems with this in the sense that we are making many simplifications. In real life, stress will not be radial. It will be a point load leading to stress concentration, but those effects we are neglecting. The same load which is causing bearing stress in the plate is causing shear stress in the pin.
Sir,
Sir,
Yes.
sir, how
in
is
case of sir,
One
in
sorry.
case of pin, okay.
Hmm. In
In
case of
case of pin, if we see the force, there is a force at the upper part as well as in the lower part. So if we are accounting for area, we have to calculate only the upper area, lower area, or the sum of both areas.
in this we'll do P by A. In this, is this a double pin or a single pin? This is a double pin. So we'll do P by A, no? No, no, there is only one. So it will be F by A. Shear stress is F by A. A is the circular cross section.
Sir, when we look at the plate, we can say that the area is the complete area. But if you are calculating the stress or the bearing stress by looking at the pin, then what area we will see?
By, I did not understand your question. I'm looking at this free body diagram and I'm saying shear stress is F by A.
Sir, I'm saying that if we look at the free body diagram of the pin,
Pin, yes.
yes, sir, then and we are calculating the stress by looking at the.
So it is F by A, na, cross section. The shear
Yes,
stress is,
sir, but there are two forces, so we will calculate for the two forces or only one force.
they are equal and opposite the forces. One is both are reactions. It is F by A.
Okay.
No,
hello, sir.
yes.
Sir, there is a problem in part two, in the stress part two. Can you
Okay.
show this? That, sir.
Mm-hmm. Which slide?
Sir, slide number 6.
Yes.
Yes, sir. Uh, sir, one more above. Sir, slide number 7, sir. Sir, slide number 7.
This is slide number 7.
Yes, sir. Sir, could you discuss the forces on pin?
Which pin?
Sir,
Pin at C?
pin at B, sir.
In this?
I think that is in the 8, sir.
This one?
Yes, sir.
1 minute. We discussed this. So in this, na, what is happening is this. So this pin at B is connecting together three components. This hook from which load is applied. There are two members, there are two parts from member AB and one from BC. 1 and 5. In 1 and 5, the portion of the pin named 1 and 5, the load 30 kilonewton is applied equally in both of them. So 15, 15. In 2 and 4, the force FAB is equally distributed. And in 3, the FBC is applied to the pin. So this pin is actually connecting three members, and out of those three members, the hook has two arms. The member AB also has two arms. So the free body diagram will look something like this. So this is my applied load, 15, 15. This is because of this.
Sir, could you explain the direction of FBC, sir?
Direction of FBC is along the length of BC. BC was a two-force member. FBC is 50 kilo, so it is with respect to the pin, it is this direction, this one.
Okay, sir. Got it.
Now, once you do this, you realize that at different sections of the pin, there are different loads and the cross section is same, so there are different stresses. We have to identify the cross section where this load is highest, which is in this region, and calculate the shear stress based on this. Okay?
Sir, what did you say? Can you say once again?
I am saying that there are 5 parts. There we notice that in the pin at 5 different points loads are applied, and these loads are not the same in value. So at least 5 different regions the load is different. Now, but the load is different, but the cross section is same. So the stress is different at different sections. We will identify the region where the load is the highest and calculate the shear stress based on that load. In the region DE, force is 15 kilonewton. In the region EG, it is 20 kilonewton. In GH, it is 50. So we have to calculate the shear stress based on this 50 kilonewton.
Sir, we will calculate shear stress for higher forces.
Yes, because the shear stress value will be highest. Na? We want to calculate. In general, we are interested in the highest value of stresses, not the lowest value. And since the cross section is circular, for shear stress, as long as it is in one plane, the direction doesn't matter. I mean to say that, imagine that this is my circular cross section. Okay. If the load is in this direction, or case 2, again I'm doing a circle. If the load is in this direction, if this is equal to F and this is equal to F, the shear stress area, the shear stress is still F by A. We are saying, all we are saying is force parallel to the surface. We are not saying anything about the direction. So the fact that the direction of Q, half FAB, FBC are different doesn't matter. All the forces are parallel to the circular cross section. Okay? Is this point about direction clear? I am trying to say that since I have a circular cross section and I am defining shear as force parallel to the area, then force by area. We are not making any statement about the direction of the force other than the fact that it should be parallel to my cross section. If it is circular cross sections in both the circles that I have drawn, it is still parallel. So the direction doesn't matter. You can, it doesn't matter that Q is downwards, AB is right to left, BC is at some intersection. All the forces are parallel to the circular cross section. So we'll just say shear stress is force divided by the area of the circular cross section.
Sir, how does 25 kilonewton is?
Because this is a double pin. In GH, there are two surfaces which are opposing this load of 50 Newton. One is this cross section, the other is this cross section. We have to treat it like a double pin. Or I mean, let us draw the free body diagram of the region GH, okay? Okay, clear?
So it won't get a reaction from other pin portions.
So we are actually looking at,
They all are connected.
no, let's say just beside the pin. I mean, just beside the applied forces in both the cross sections, then no. The answer is no.
So we have to take only one shear force for calculation of shear stress.
Yes, you have to identify which is the highest and take that one.
No, sir. Here you have taken 25 kilonewton.
So it is on that surface. So either you do 50 divided by 2 into pi r square, or you do 25 divided by pi r square.
Okay, sir.
Okay, anything else, or let's go to problem sheet?
Excuse me, sir.
Yes.
Sir, about the
sample
factor
problem.
of safety. Sir, the factor of safety thing that you taught us, in that we always consider the minimum amount of factor of safety to be the factor of safety of that machine
Yes.
or that arrangement.
Yes.
And so factor of safety is the ultimate stress divided by allowable stress, and that means that we can calculate the factor of safety for each of the different types of stress at each of the different members of the body, and then find out the minimum, and that is the factor of safety.
You are.
I mean,
basically what we are doing is we will calculate for every component the
yes, sir.
stress, and then for every component we will calculate the factor of safety.
Yes, sir. The stress means we will calculate the normal stress and the shear stress at each of the components. If I mean both are applied, both are acting
Yes.
in that case.
Correct.
Okay, sir. Okay, sir.
Sir, in punch hole problem in sample question,
Wait. Let's this factor of safety, but be careful that this is again simplification. As you go deeper into engineering, you will learn about theories of failure, that if normal and shear stresses are happening at the same time, then what will happen, then how do you use factor of safety, etc. But in a general simple case, within the scope of this course, you are right. Yes, punching hole, something you were saying.
sir, in punch hole question, sir, first means how the effective area is calculated where the total force is applied. So means you did 2 pi dt. Sir, I thought it was pi dt.
2 because there were 2 holes.
Sir, I thought that the force must be 50 by 225 applied at pi dt.
N into pi dt. That's what
Yes,
I've done. 50 by 2 and n pi dt is in the denominator.
sir, in the second line, sir, relevant area is 2 pi dt. So means it is basically the same. Either way, we can solve.
Right.
Okay.
Sorry for the typo. I just noticed. It should have been this. Huh? This bracket was missing. Sorry.
Yes, sir. Yes. Thank you, sir.
Okay, good. Anything else? Factor of safety should always be greater than 1. If the factor of safety is less than 1, then your machine will not be able to undertake the function it was designed to function. Okay.
So in one of the questions, the factor of safety was coming around 1.012. So isn't that machine going to be very prone to failure? Like it is very close to one. In one
It
of the
is good,
questions.
but
Yes, yes, yes.
factor of safety is a very complicated. In my video also I said, now it is usually the job of a very experienced engineer to decide what the factor of safety. Factor of safety will be depending on so many things. Is it moving or not moving? If it is moving, Swastik, I will come to your question. Huh? 1 minute, let me complete this, then I'm coming to you. So, for example, if it is moving or not moving, the other could be what will happen if it fails? What is the sort of loss that we are looking at? What is the cost for increasing? So, for example, what was the factor of the safety when the Howrah Bridge was first designed? What do you guys think? What should be the number? The old Howrah Bridge, all of you know, now 150 years old approximately. What is the factor of what was the factor of
Yes.
safety when it was first designed?
10 to
So 3 or
15.
4.
148. And in the aeroplane that you fly, what is the factor of safety in the most critical component?
500.
Around 400.
Yes.
Around 400.
So 200.
You will be very surprised it is 1.1. If you start doing 200, 400 factor of safety in an aeroplane, it will not fly. It will become so heavy. Things so it's very complicated because in an aeroplane, first of all, it has to fly. If you go for very high factor of safety, it will not fly. It will become very heavy. The second thing you have to keep in mind is that an aeroplane can never be designed to and no, Soham, there is a reason. So it is 1.1 because of many reasons. One is, how many of you have been part of an accident while riding a car? Riding a car, you're not driving, riding. Mild accident, auto rickshaw hit you or something happened in the car. Mild accident or big accident, almost
So
everybody.
school bus.
Yes,
School
sir.
bus.
Yes, a school bus, same here.
Almost all of you have suffered, have been part of some. How many
Yes,
of you have
sir.
been part? How many of you have been part of an accident in an aeroplane? Nobody.
No, sir.
The reason is that
We
first of all, in
didn't
a car,
ride
So if you
that
have, you wouldn't
much.
have been here.
that's what. So in aeroplane, when you are designing an aeroplane, you only have to design it for regular use. You can assume that the pilot will never come up drunk. You can assume that there will be no traffic jam. Nobody will try to overtake you. And you can also assume that if there is a crash, there is no way you can save human life. So you will go for very low factor of safety. On the other side, in a car, driver can be drunk, road can be bad, people can overtake. So the factor of safety will be like 3, 5. So it's not just, it's not just it's not just like a question of, okay, if it's an expensive equipment, let me make high factor of safety. It is not expensive, then let me make low factor of safety. It doesn't work like that. It's very, very complicated. It can be possible that there are some components that you have used in your daily life and the factor of safety was 1.01 and it just moved smoothly for you. Nothing happened.
So stress can be generated from internal factors also, no?
Like, I don't understand your question.
No, I mean I don't know what, but can it be?
So
Stress
I
is the
was saying
reaction force. It is the reaction force divided by the area. So it's
It
the
is the
reaction
reaction
force that
force
is generated.
that is
internal
generated.
force only.
It is the internal force. Yes.
So I
Which
was saying that if perhaps in an aeroplane, suppose a storm comes by, then would it not undergo a lot of stress due to the storm in the
it
opposite
would
direction?
it would go, but then you factor of safety. There are only so many things you can control. If there is a storm, even if factor of safety was 2, it would not be. I'm not saying that the factor of safety in the entire plane is 1.1. In the most critical component, it is 1.1. So maybe the wings and the fuselage is susceptible to the storms that you are talking about, but maybe the most sensitive or the most critical component is hidden somewhere that it does not care. I mean, the storm will not be
Yes,
able to
sir.
affect it. I,
Yes, sir, got it.
don't interpret my statement as the factor of safety is 1.1 for all the components. For the most critical component, it is close to 1.1. Okay.
Yes, sir.
Yes, sir.
Soham, you should fly in an aeroplane because statistically, aeroplane is the safest mode of transport. It is even safer than riding a bicycle. The per capita accidents and deaths riding a bicycle is higher than the per capita deaths when you ride an aeroplane. Strange but true. Aeroplane is the safest mode of transport today.
But sir, number of people flying in an aeroplane is very less compared to
That's why
number
I'm
of
saying
people
per
driving
capita.
cycles. That is also
I'm saying per capita. I'm saying per capita statistics. I'm not saying the number. Per capita means if 100 people fly. So if you are flying an aeroplane, what is the probability of you dying? And if you are riding a bicycle, what is the probability of you dying? In the second case, the probability is higher.
Yes, so but that is quite linked to the sample space of the cyclers and the aeroplane flyers.
But both of them are above a certain limit. It's not like I'm saying 2 aeroplane flyers and 1 million bicyclers.
Yes.
Aeroplane also is above a certain number. It is not, the sample size is big enough.
Yes.
Okay, so Swastik was asking in problem 4, what does the reinforced refer to? Problem 4, presentation 5, is it? Swastik? Problem 4. This one, okay. So reinforced means this.
Oh, भाई मैंने कर दिया.
So let's say you have a member which has a hole like this, okay? Now the cross-sectional area in this region will become low. Yes? So the sample, there is tendency that it might break in this region. Because you have punched a hole, you have reduced the cross-sectional area. To avoid this, sometimes at the ends where you punch a hole to fit the pin, you will put slightly more material like this. This is the reinforcing of the whole region. In this problem, we are saying that this has not been done. So you have to consider the reduced cross-sectional area. Clear, Swastik?
Yes, sir.
Okay, good.
Sir, means the 18 minus 1 is done because of reduction in length.
18 minus 10 is done because of the reduction in the cross-sectional area. So I mean, what 6 was the thickness, is it? 6 millimeter diameter, 10. What was 18? 18 minus.
Oh, sorry. 18 minus 10. Yes, sir.
10,
I got
18
it.
18 minus 10 into thickness. ठीक है. Okay, good. Okay, good. Anything else, or let's go to problem sheet? I think problem sheet also, it's few of the problems we have already discussed in the video 5. Some of them we have not discussed, so let's have a look. So please try to solve this problem.
So this one part B is not matching.
That's why. That is the catch.
A is
So
also
it,
not coming.
Sir,
no,
A
A
is
is
not
A is
coming.
coming.
coming,
A
sir.
is not coming. B now.
A is correct.
A,
B is
A is correct, sir.
A is
A is
coming.
coming. A is coming.
B is not.
B is not coming. Why? I can tell you this answer is right. Hint is given here.
Sir,
the
what does it
different
mean?
cases you have considered. Sometimes you have to consider the stress, and sometimes you have to
So
consider
actually, we
not
have to
stress.
Oh,
subtract the
acha, acha, acha.
area
Got
from
it.
the diameter of D in second part. So
Yeah, I did that. I did that. Okay, I didn't consider the critical one.
For the benefit of those who do. That's why I wanted to discuss this. This is a very good example of this topic of stress might seem like it's very easy, but there are many hidden points. So let's take this, or let's do it here. Okay. So now the first case, load is like this. Okay. Okay, it is like this. Yes, when theta is 0 degree, you will get tensile. When theta is 90, you will get compressive. Something like this, correct? Now, because of this, what is happening is that the region above this black line will be stress free. Because stress is transferred through the tip of the hole from the pin. That assumption we will make. In this case, this is the region which is subjected to stress. Now, can you identify the critical region? For tensile, it will be width minus diameter into T. For compressive, it will be diameter into width into T.
So,
Sir,
can you
again explain
Sir, excuse me, sir.
Hmm.
Sir, for the case B in which there is a compressive force, I did the diameter into T. I divided by diameter into T only, but I am
Width
getting the answer divided. Yes, sir. That we divided.
width into
Yes,
T.
sir. Yes, sir. With into T. But sir, I am getting the answer as the given answer divided by root 3. I am getting 48 point something.
No, no.
yes, the
40.
same also I was also getting.
What is the value of FBD? When
So
theta is 90
FBD
degree,
is
when theta is 90 degree, what is the value of FBD?
Sir, 30
FBD is
kilonewton.
10 root 3 kilonewton.
No, sir, it will be 30 kilonewton in case of
No,
A.
30, sir. 30.
yes,
30 kilo.
Oh, then I missed a root 3.
Let us come to this. How many is the point that I'm trying to make clear with these figures, with this schematic?
Sir, I
No,
don't
no,
understand
sir.
the part here.
Okay. Okay. So what I'm trying to say now is that when so this is a member with two holes so that it had pins, and the load in this member is being transferred from the pin to the member. When the load is tensile, this tip here is the region where the load is being transferred from the pin to the member. And when it is compressive, it is through this region. the region above and below the points that I have drawn, the load is 0. So this region is stress free. This region is stress free. Stress free. This region is stress free. Only this region is in a state of stress because the load has been transferred at this point. Beyond that point, there is no load in the member. So while calculating for tensile, I have to find out the critical region within these limits. So it will become hole minus diameter. This region is where it might. Okay. But here that hole is not there. Already at the tip of the hole, the load was applied. So everywhere it is D into T, width into T.
So can you explain the last part again?
So these black dotted lines that I have drawn are the regions where the load is being transferred from the pin to the member. Beyond this black dotted line, the regions are stress free. So we have to find out the critical region within the limits of this dotted line. It will come out that it is somewhere in the middle of the hole. There it will be width minus diameter into thickness. However, when it is compressive, the load is already applied at the tip of the center. So the limits within the dotted line, the cross section is now uniform.
So in the first diagram, then if you consider somewhere in between the two holes, then it will be width into T only.
It will be width into T, but we want the maximum. We have to identify the critical region. So in the first case, the critical region is this.
It's 0.
Okay?
Yes, sir. Now it's clear.
Yes, sir. Yes, I got it.
This mechanics of materials is like a endless well. I mean, there are so many complexities, so many nuances that you will only learn by practicing. This, for example, this is one example. It looked like a very simple problem, but when you try to solve it, it is not so simple. Okay, 2 everybody managed to do?
Yes, sir.
So now if I look at the problem sheet, problem number 2, so if I look at this, problem number 1 I have done already, yes, as a part of the video. Very similar to this. It is slightly different here.
Yes.
In that diameter was given, stress was
Yes,
to be
sir.
found. Here stress is given. This is
Yes, sir.
2 we have discussed. 3, 4 we have not done. 5 was discussed in great detail. 7 was discussed. 8 is discussed. 9 is discussed. 12 is discussed. 13 is discussed. So many problems we have done. So which problem should we solve now?
Sir, I have a doubt in
So
9. sir.
third. So I have doubt in third, sir.
Tell me. Are you getting this number? I think I am getting 272. Did anybody get this number for question answer number 3, 285.33?
No, sir, I'm not getting
Ye-
that.
Yes, sir.
I
I
got
got it.
285.33.
Yes, sir, I got it.
Yes, sir, I got it. Yes, sir.
Where did you put the middle P?
So on the
Back side.
longer that
Backside
wait,
means
left
AC.
side, yes.
Or portion AC.
Yes, sir. Yes.
P by 2 on both the sides.
It will be divided unequally, sir.
So do you put it in BC as it is shown in this, because BC is thicker?
So, sir, I put the P value in
Sir,
pin, sir. After the FBD of pin gave me the forces.
So the middle force is applied on the pin and then you draw the equations, is it?
Yes, sir.
sir, I have done P force applied on AC and a reaction force due to pin in the both CD and AC and in opposite direction, and then we have calculated.
In the two cases, does the answer come out to be different or same?
Sir, answer is coming, sir.
And the first student who put it in the pin, did he also get?
Yes, sir.
No, sir. Sir, after equilibrium, it would become C by 2, P by 2, P by 2 on both sides.
No.
Normally, the third P, you can put it anywhere by using equations of equilibrium. It should balance each other. I mean, irrespective of whether you put it in member AC, CD, or the pin, and then if you write the equations of equilibrium correctly, it should take care of itself. Our choice should normally be irrelevant.
Sir, but from question it is acting on AC because AC is thicker.
But from AC again, the load wouldn't be transferred to CD. I am confused about that.
Sir, whatever case we take, the force at pin C would change, but net effect should remain same.
That's what I'm trying to say, yes. So my one thing, but if you do, it comes out to be wrong. One thing I can tell you what you'll wrong. If you start putting that, okay, let me replace the 3 P's of 4 kilonewton into 1 P at the pin C is equal to 3 P. So if I put 12 P, 12 kilonewton directly at the pin C and try to solve, then I think it gives the wrong answer. All other approaches should give you the correct answer or the same answer.
Yes, sir, because the moment would get distorted if we do that.
If you put all the 3 pins, all the 3 P's in the pin and add it up and say it is 12 kilonewton, then I think you will get 272 millimeters or something like that, which will be wrong. All other approaches are right. You can put it directly in AC, you could put it in the pin, you could put it in CD. But write the equations of equilibrium carefully. I think you should get the answer in all the 3 cases.
Sir, and it is 0.1 each length.
Yes.
Okay then.
Please try to solve this, those who have not solved. And those who have solved it, you can try question number 4.
Sir, I had a doubt in question 9.
We'll get there.
Okay.
We'll get there. Four again, I think, is very similar to 3 in the sense that it is a body in the state of 2D equilibrium. You will calculate the force in member BC and then you will calculate the stress, right?
Yes, sir.
Yes, sir.
Yes, sir.
So I think with this concept of stress, you are beginning to better appreciate why we did 2D equilibrium in so much detail. So 2, 3, 4, everybody has done. Can we move to the next one, or let's wait for 5 minutes? Let everybody finish problem 2, 3, 4. Let's try to finish as many as possible in the tutorial itself for the whole class, so that in the weekend you have less work to do, or you can try and solve other problems in the meantime in the weekend.
Sir, this weekend we will have assignment.
Yes. This week you will have, next week you will have, and that will be the last assignment. Today a new video will also be out, or new videos will also be out.
So total 9 topics or 8 topics?
It is 8A, 8B. Rather than 8 and 9, you can imagine it as 8A, 8B. The 9th topic is actually 8B.
Okay, okay.
Topic?
2, 3, 4. Any questions, anybody, or can we move forward? Okay, let's move forward. 5 we have done. Question 6, could anybody do, or anybody has any doubt?
I have a doubt in 6th.
Yes, tell me what is your doubt. This is the question.
Yes, sir. So, for calculating the shear stress in the two wooden plates, wouldn't it be like distributed like 24 by 2? 24 by 2 is the force, and then in the area we take like L minus 8 into that width. Because the answer was matching if we take 24.
Huh.
Sir, for the shear stress here, are we considering both the surfaces?
Yes,
Okay.
both the surfaces we have to consider, but then I did it as 24,000 divided by L minus 8 into 100 is 800 into 10 to the power minus 3, meaning that 24 kilonewton is applied at both the ends. They are not, because there is a gap, 24 kilonewton applied at both the ends.
Yes, sir, but there are two wooden members, right? Like A and B. So wouldn't the force get distributed like half in each?
Area will also become half, corresponding area.
Yes, yes, the area will also become half.
Okay.
Actually, this figure is not nice, I think. A few lines are missing. It is not a good 3D figure, but still.
If color was added, then it would have been better. Different colors being given to the different boards.
No, actually, this line is missing. I'll tell you what is wrong.
Yes, sir.
It is like this. This line was missing, I think. So 24,000 is the load divided by L minus 8 into 100 is equal to 800 into 10 to the power minus 3. Solve for L, you should get the answer. I think this question was put to first check whether or not you are able to visualize the different surfaces, and to make sure that you understand that you should not be careless about the units. Kilopascal, kilonewton, and millimeters. So you have to do some unit conversion to get it right. Okay, is this clear, everybody?
Sir, in this, for area, we have to take L minus 8 into 100.
Yes.
So actually I'm not getting that. The area is from both sides, na? From front and back side. So why we are not taking 2 times of that?
It is L minus 8 2, as you say, but by 2. L minus 8 by 100 because it is this length. From the center line to the top.
Okay, so got it.
So why you did into 2 by 2?
By 2 because I'm looking at only half of the shear surface. Let us only look at the shear surface between A and the block. 2
Yes, sir.
2 because it is on both the sides. Okay. 7, I think all of you can do. Yes, we have solved a very similar problem in the videos that I shared.
Sir, I have a doubt.
In which number?
Means I have a doubt in theory that in many cases we are given maximum allowable shear strength. So is that only a material property, or there are other factors affecting it?
It is usually allowed or ultimate.
Ultimate.
Ultimate is a material property. Usually you will make a sample, you will go to a lab and you will apply loads in a universal tensile machine till it breaks. And that is a material property.
Okay, sir.
There are standards. I mean, depending on your sample size, you might get slightly different values, but there are well-established standards that to get the correct value of the strength, you have to make samples like this. You have to do tests like this. If you follow all the standards, you will get a value which is independent of the type of testing, only the material property.
Okay, sir. Thank you.
But because all the one important point, even though these problems will never mention this, but as an engineer, you have to appreciate that if you do n number of tests, you are likely to get n slightly different values. And the values that we use is usually the mean. Either the mean or the limit, the 90% confidence limit. So these are the numbers that we are actually taking. So don't think that the ultimate shear strength of aluminum is 275. It does not mean that every time I take an aluminum sample, it will always break at 275. Sometimes it'll break at 270, 273, 278, etc., etc. Maybe this is the average, maybe this is the 90% confidence value.
Okay, sir.
Okay. So 7 I am skipping. I am assuming all of you know how to do it. 8. Eight is the same logic as 2.
Yes, it is same, sir.
9, somebody had doubt.
Sir, in ninth number,
Yes.
what is meant by shear stress on the bolt?
Shear stress on the bolt. Yes, it is F divided by A square, pi r square.
Pi r square.
In the bolt, that's how we calculate, no? Shear stress. This one.
First,
Yes.
okay, sir. Then what we will call the stress that is applied on the sideways of the bolt.
Sideways of a bolt means, let's draw a bolt and then you can explain to me. Let's go back to our free slide. So we are saying that this is the top view of a bolt. This is the side view of a bolt. Okay. Then this is causing shear. Okay. Let's also draw a 3D figure so that we are 100% sure of what we are talking about. So this is a simple cylinder and this is causing shear. Which sideways are we talking about?
Sir, if I consider my bolt to be cuboidal shape, then the
bolt is cylindrical.
yes, sir. But I'm saying
okay.
So that okay. So the face of one of the cuboid will be facing bearing stress.
So I think cuboid, all the sides are same. It will lead to more confusion. Tell me, which face are you interested in? Are you interested in are you talking about the load in the rectangular face or in the circular cross section?
Rectangular, sir.
Okay, so in the rectangular, what will happen, you think?
I'm saying that the steel plates are kept one above other and the bolt is used to tighten them. So when I pull the steel plates, there will be stress on the side part of the bolt too.
No. That will not happen because the two forces that are there on the steel is not concurrent. It will be something like this. This will cause shear, not bearing. Bearing would happen if it would be this. But there is one plate on top of the other. So it will be like this.
Yes, sir. Now, if I consider the side parts or
Hmm, hmm.
side walls of the bolt, then that would be shear stress, right?
Which side wall? AD?
Yes, sir.
No, why is the two forces that I have drawn are parallel to the circular cross section, so it is shear stress. The bolt will not be in a state of compressive stress because both my two forces are not concurrent. They are slightly offset from each other. For my bolt ABCD to be in a state of compression, it should have been this. But that is not happening. It is the two plates are not, they are one on top of other. They are not parallel. So there is no compressive stress.
Sir, in the ninth question, you said the shear stress is equal to F by pi d square. Yeah, pi d square by 4.
Ninth problem, the shear stress, yes. So it is
Uh,
F divided by pi r square, this area.
yes,
This
sir.
yellow
So you
area.
So since there are two pins, so it will be divided by 2 for each of the pins.
That I'm not going to the specifics of this problem, but in general, in a bolt, the relevant area is pi r square.
yes, sir. But I'm saying that you are considering the cross-sectional area, but I'm saying the area that is contact with in the sideways of the steel plate.
But there is no equal and opposite. That's what I'm saying. The force in face AB and the force in BC are not concurrent. They are not equal and opposite. They will not cause normal stress.
Not talking about normal stress, sir. Shear stress only. In the face of ABDC, sideways.
Right. Yes. Yes. But the force is parallel to the circle.
Yes.
So it is shear stress, and the relevant area is area of the circle.
No, sir. The area would be D into T.
No.
The
Why should that be? It would be D into T if there would be something like this. And on both the sides.
Yes, sir. That is the case in ninth.
No, it is like this.
Okay. Okay, sir.
This is this dotted line. This dotted line means that the second plate is below that.
Okay. So if there was a uniform force all over it, then it would be D into T.
Right.
Okay.
Another way of imagining now whether it is normal or shear, one useful way is to keep in mind that if there is a rectangle, if there is a square and it is subjected to normal stress, that square will become rectangle. If there is a square and that shape from square wants to go to rhombus, then that stress is shear stress. Normal stress changes size. Shear stress changes shape. That could be another way of imagining. Because of this yellow loads, will this rectangular, let's say, and it deforms, will this rectangular remain rectangular?
Sir, in this case, what is area?
Parallelopipe.
Paralleloparallel, but I mean, if you make small, it will be a paralleloparallel or rhombus. So that is shear. If a rectangle becomes a rectangle, but the aspect ratio changes, or if a square becomes a rectangle, but the 90-degree remains constant, then it is normal stress. Change of shape is caused due to shear. Change in size is caused due to, no, change in shape is due to shear. Change in size is due to normal stress. Like, let us look, okay, let's make another simple illustration. Let's say this is a square and I apply some load. Okay. After I apply the load, you will learn about it also in the next topic. My shape will become something like this. Agree or disagree that if I apply a load to a square, the tendency of the body will be to increase like this, correct? So this is change in size. This 90 degrees are remaining 90 degrees. Now let us look at another example. This time we are going to, let's think that one end of the body is joined to the ground. Okay, it is attached to the ground and I am applying force like this. And I'm applying force like this. So what is likely to happen? Most likely, it will go like this. This is change in shape. This is shear, this is normal. Is it clear now?
Yes, sir.
This will most likely go what will be the shape? It will become like a maybe the bolt will become, wait, let me. Maybe the bolt will become something like this, yes, because D wants to come, D will be pushed slightly to the one side, A will be pushed here. So it will become something like this, is change in shape, not change in size. So this is shear. If both of them were like this, then the length of AB would reduce. If the length of AB would reduce, then we will causing, that would be normal stress. Okay?
Yes, sir.
Okay, good. So,
Sir, in seventh, sir, why it is not taken as a double shear?
seventh, what have you done? Did you, so what is the answer? It is
P by 2 divided by pi dt.
275 is equal to P divided by 2 pi R into T. Is this what you have done?
No, sir, 2 pi r p by 2 divided by pi dt.
P by
So the
2.
so the 2 are
Why this 2 is coming? Why P by 2?
Sir, means in the this is similar to the figure in double shear you have shown in the slide set 2.
There is a slight difference. Slide presentation 2 I said, na?
Yes, sir, 2 last page. Yes, sir.
This is not punching machine. Single punch is there.
Here in this, it was my bad. It is not mentioned clearly, but the thickness of this punch is the same as the thickness of this plate. But in our this problem, it is closer to this problem, but with only one punch and a hole.
Sir, means the slide set does not have a circular hole.
Yes, it is. This is something that you do while doing a shear test. It's like the width of this indenter and the width of this plate is the same.
Sir, means in this case, can you specify the area? Then it would be more clear.
Area would be
Pi dt, sir.
So it would be this thickness into this width, this area. This area.
Okay, sir. Sir, means whenever punch hole comes, it is a circular hole. Therefore, we take pi dt, no p by 2.
No.
Yes, sir.
See,
Circular hole. Okay.
actually, we are taking the entire surface which is getting sheared. In this case, the entire surface that would get sheared would be this, both the surfaces, right?
Sir, so we have to divide the force by 2 only when there are two different surfaces, means a rectangular slot is there.
You can imagine it that you are dividing the p by 2, or you can say that you are accounting for both the areas.
Okay then. But in circular, we take
Circular
the entire.
also circular actually we are doing p divided by infinity, but multiplying it by small infinitesimal. You can also imagine it like that. Na? It is the same thing that we are doing, but it's a circular hole. So
Okay, sir. Yes, sir.
We are saying it is p divided by infinity, but multiplied also by infinitesimally small part, and integrating it over the entire circle, you will still get the same result. Basically,
Yes.
force divided by the entire area which is getting sheared. It could be a circular area, it could be two parallel rectangles, it could be anything. Just you make sure to account for the entire area that is being sheared. Understood?
Yes, sir.
Okay, good.
Excuse me, sir. Sir, in any component in which we are measuring the shear, if we are measuring the stress, we are telling that the critical section is that part where the stress is maximum.
Yes.
Okay, sir.
Because that is where it's likely to fail.
Yes, sir.
Shear on the walls. On the wall, usually on the surface of any body, stress will be 0. Because the outside walls are free to expand.
No, sir, I got it. I was asking about this only, the nuts wall.
Okay. The surfaces are in a state of what we call plane stress. Plane stress means the surface will have only stress components, which are all the stress components in a surface with outward normal will be 0. I mean, if the outward normal of a surface is x, then sigma xx, tau xy, tau xz all will have to be 0. Okay, ठीक है. 9 is done.
Excuse me, sir.
Yes, sir.
Sir, can you show me FBD of question 4? My answer is not match.
Question 4.
Yes.
After the class, I could draw, I could scan it and send it to you, but currently I don't have it.
Okay, sir. Thank you.
You are Karan, na?
Yes, sir.
Okay. I'll send it to you, or I will share it with everybody. Okay. Eleven. What is the answer? How do we solve it? Which is the correct area for shear?
So Piers,
bearing stress.
Sir, in 10, my answer is not matching.
10. What is the diameter at B? So at B, you had both x and y component, yes?
Yes, sir. 30.
Did you do square root of bx square plus b?
No, sir.
Again, recall our discussion about shear stress at a pin. The magnitude of the force is mattering, the direction doesn't matter, because as long as it is parallel to the circular cross section. I think this problem is given to ensure that you understand what is double pin shear and that you have to take magnitude of force, not only Bx or By. Try and then you will get, please try question number 10. What is the value of Bx that everybody is getting?
30 kilonewton.
And By?
30, sir.
30 kilonewton.
Bx is equal to By is equal to 30, is it?
Yes.
Yes. Yes.
What is B?
So both 30.
30 root 2?
30 root 2.
So 30 into root 2.
And based on 30 root 2, can we calculate?
Yes, sir. We can calculate.
So 1000 is equal to 30 root 2 into 10 to the power 3 by pi r square. What is the value of r? Pi r square is equal to 300 root 2. And it is, keep in mind that this is double pin, okay? Account for that also. I am getting 16.434 millimeters. I think this is the mistake you have made. You have just taken the value of Bx and By, but you should take square root of Bx square y plus By square. To understand that, let us go back to our in this one, where this point that I was trying to make, the direction of F doesn't matter as long as it is parallel to the circular cross section. We are okay. The direction doesn't matter, but the magnitude matters, and the magnitude is square root of Bx square plus By square. That you have to be careful. Okay, everybody understands this? Tanmay, Miriam and Craig is for statics only. Beer and Johnston have written a book also in mechanics of solids.
So I was saying that if I have some problems in solving, like the solutions and answers
We can
don't
try to
match.
solve. Obviously, we can try to solve, but the only condition is I will not send you the solution alone. I will upload it in the Teams. Everybody will be able to see.
Oh, okay, sir.
Okay. So 10, everybody understands how to do. Everybody gets the answer. Everybody, please make sure in a pin, if there are two components X and Y, then the force which you will use for calculating the shear force has to be the resultant force, not Bx, not By, but the resultant. Okay. Does everybody understand why we are taking the resultant? Not Bx, not By, but the resultant.
So along the resultant, there will be the net force, no? So the
Yeah.
area.
So but it is still parallel to the area.
Yes, sir.
Excuse me, sir. Sir, I'm not getting the D part or the last part of question number 9.
How much are you getting? 225, is it?
Yes, sir.
225. You are getting double or
Yes, sir. Approximately double, not exact double.
did you account for the two surfaces that are there? D into T into 2? Hello, yes, did you take D into T into 2?
No, sir.
That's what I think.
Okay, thank you.
In the tutorial, I miss the most in-person teaching. In tutorial, there will be many teaching assistants. I think this is in mechanics. The fact that there are no teaching assistants who can participate and the fact that we cannot go around looking at everybody's copy, that is hurting your little bit, I think, learning that you are doing in the mechanics. Other subjects, how it is going, the tutorial classes?
So in the physics of waves, the tutorial class, the TA that I have explains very nicely. So that tutorial I like.
So you have what, like 45 students per TA, something like that? Some.
Yes, sir.
Yes, sir.
Approx 30 student.
Yes, sir. Yeah. 31, I put.
Could have done that also.
But in that case, professor is not there, only TA is there.
Yeah, and then there is a lot of, I think, variation. Some TAs are good, some are not good.
Yes, sir. Yes, sir. That is taking place.
So the same TAs throughout the section, or I mean, the TAs are also rotated so that everybody experiences all the TAs.
No, TA remains same.
No, sir. TA are remaining same, sir, for whole.
That is risky, no? Suddenly, one group might be at a great advantage and one group might be at a very big disadvantage.
Yes, sir.
Yes, sir.
Okay. Usually, I mean, in a classroom setting, it is like we divide the class into 5 halves, and there are 4 TAs and myself who are roaming around checking your copies. That would be the normal if it was a offline campus, it's offline semester. Okay, never mind. 10, problem number 10, anybody who is not getting the correct answer? $11.
No problem, sir.
11, anybody who did not get this, or anybody who got this, can you explain what area you have taken? For the bearing stress, what is the area?
So actually we have to take the area, means whole the pi r square minus pi r square, means radius of outer surface minus radius of inner surface.
No. My point is,
Sir, area of the annular region at the bolt means pi d square minus pi into 25 square divided by 4.
let's draw the top view. This is also historically a question where students are. I expect that there might be some struggle. So, and then there is another circle. So from the top, it looks something like this. I'm drawing not to scale, but something like this. And then this is given to be 22, is it? This is 22 millimeters. This green arrow, let's make it green color. The green arrow is 25 and black arrow is D. So now the question is, which area should we take? Should we take pi into d square minus 25 square by 4 or pi into d square minus 22 square by 4? Which is the relevant area?
So first one.
It is actually going to be it is going to be this gray area, right?
Yes, sir. It is this area between the outer two most circle, this region between this blue region, which is the diameter of this pin, and this 25, there is no contact between the pin and the wooden bar. So the bearing stress will be on this annular region, which is between the two outermost circles. I think if you get this, then the answer should come. Yes, sir.
Everybody understands this?
Sir, can you repeat once?
So I'm saying that if you draw the top view of this, you are going to see a circle with a hexagon, but that hexagon is an irrelevant detail. So this circle is coming due to the innermost hole. Okay, this hole. So I'm imagining that this bolt is actually sort of transparent. So this inner diameter is 22. There is a 3 millimeter clearance. So the hole in the wooden member is of 25 millimeters. The pin is 22 millimeters. This variation is done so that the pin can fit inside the hole easily. And the outermost diameter is D. So the region of contact between the pin and the wooden block is the annular region between diameter D and diameter 25, not 22. It doesn't matter if it was 22, 21 or 24.9. As long as it is below 25, the annular region between diameter D and diameter is equal to 25. That is our region for interest for the bearing stress.
Okay, sir.
If you have to calculate the tensile stress in the pin, then the diameter 22 is important. If you have to calculate the shear stress in the wooden block, then what will you do? Which area you will take? The curved surface area with diameter 25.
So pi dt, d means the outermost radius. diameter of the washer.
To the curved surface area under the outermost diameter. 2 pi d into t. That is right. Sorry. Mind. Okay. ठीक है. Understood? Everybody understands 11?
Yes, sir.
12 we have discussed, I think, in our videos or in our doubt clearing yesterday. 13 has been done. Also in our videos, I think there is nothing unique about this. Fourteen also we have done. I mean, the problem number 2 and problem number 14 are not very different from each other. Problem 14, anybody is having a problem?
Sir, here we are means if the direction of P was opposite,
If the direction of P was opposite, yes.
then BC would be in compression.
Compression, but the point is now, since the diameter of the pin is not given, we are making the assumption that the diameter of the pin is negligible as compared to the width.
Okay.
So how do we solve this? You will draw the free body diagram of member ACD, calculate the load in BC. BC is a 2-force member, and then you can calculate the width W. Okay, anybody who could not do this problem? I would request all the 114 attendees of this meeting to try and solve this. I mean, to try and solve as many problem sheets as possible during the tutorial. Otherwise, you're not making full use of your time that is given to you. See, 12 again, I think it is the same thing. Basically, it is a 2D equilibrium problem. You will solve, you will calculate the stress. 16 we've done. Let's try to do 17. Problem number 17, anybody who managed to do, what are the different modes of failure in this? So let us discuss this. I think this will require some.
So in problem numbers of 15.
15, yes.
No, sir, in 16, sorry.
16, huh?
No, sorry, sir, actually. Go ahead, sir.
So problem number 17, let us discuss. I want to discuss this. A load P is supported like this, okay? Short wooden member which is hanging from the ceiling, okay? So keep this in mind. This is an important statement. It is hanging from the ceiling. It is not joined to the ground. Ultimate strength of the hood is 60 and 7.5 in tension and shear. Of the steel is 145. What is the load P if the factor of safety is 3.2? So while calculating factor of safety questions, you have to first identify what are the different ways by which this member can fail. So what is the answer to that question?
So area parallel to the ceiling, so from that it will
No,
be.
let us call it like this. It could be
3.
double shear in the pin.
Dislodge of wood from the top surface.
Of the surface, okay. No,
And
that
a bearing.
no, wait, the dislodging is not given. It is said that it is stuck properly. It is hanging from the ceiling, and that glue is not going to fail.
But so below it can be so.
So it is
this
tension in
version,
the
sir.
wooden block. Tension in the wooden block.
A wooden
Yes,
block
sir.
may break.
So it is tension in the wooden block. For that, what surface area we have to take?
40B.
Yes, sir.
Are you sure?
No, so 40 minus diameter into B.
40 into B minus diameter.
40 into B minus B.
Yeah, yes.
If-
Sorry, sir.
So if it fails due to tension, this surface is going to fail. है ना? I mean, the side view of the wooden block will be something like this. This is my circle. The load is applied here. This is my critical region. 40 into B minus D. So what else can happen? The hood can fail due to tension. Can the hood fail due to shear?
Sir, bearing type shear.
Bearing type shear matlab?
Sir,
Double
when
shear.
deformation takes place in
bearing is not.
So vertically it can shear, sir. In
It is
wooden block.
double shear in the hood.
Yes, sir.
What is the area for that? Relevant area for double shear of the hood?
Sir, C into B minus T.
C into B minus T. What is T?
Sir, D.
No. It
So
is going
C
to
minus D by 2 into 40.
be 40 into C. Why not? This region.
So C minus D by 2, no, sir.
No.
No, 14 to C.
40 into C bus.
40.
This region. This region.
Yes,
sir.
40.
Yes,
40
sir. Yes, sir.
into C.
14 to C.
Keep in mind this is double shear. Okay. So for 2 into 40 into C is the relevant area. And what else can happen? What can happen to the pin?
Shear.
Shear, but this is also double shear.
Sir, then what is difference between means it is looking similar to bearing stress on the wood?
Bearing stress, it is somewhere here that we are not accounting for, because in compression the strength of the wood is not given. We will calculate based on the data. The bearing stress would happen, looking at the side view. It would happen in this region.
So actually I am unable to understand that shear, sir. Please can you explain again?
Which shear? Shear in the wood or shear in the pin?
So in wood, sir.
In the hood, is everything. So we are looking at this region C. It is this region inside. Now it is the shear is an internal surface with C into 40.
So C is the height up to the center of that pin, no, sir. So the area will below that pin. So we have to subtract that D by 2 now from C, isn't it?
While calculating shear, we are taking this. This region, not this blue line. You are saying we should take, let's draw it some other color. You are saying I should take this length.
Yes, sir.
This length. But then what is happening in this length? How can it abruptly? You are understanding my question? What is happening in this length?
Yes, sir. Yes, I got it, sir. Got it, sir. Actually, I was considering that from center it will be shear, sir.
But no. We are looking at, again, we are looking at average shear stress. It is so possible that in the region marked by the arrow, the value of the shear stress is low and then it is increasing. But in this course, we don't know how to calculate stress point by point. We're only looking at average values. So the entire surface we have to take.
So got it, sir. Thanks, sir.
So please solve it and tell me if the load answer is given as 10.25. If I apply a load of 10.26, what will happen?
Shearing of wood will fail. Means that from that point, the wood will fail. It will not.
So you are saying the factor of safety of the double shear in the hood is the lowest, is it?
Yes.
That is incorrect. What is the value of P so that the shearing in the hood will start?
Sir, so here for shear stress, you have taken area 14 to C, but load is not along that area 14 to C.
Which load? But we are looking at average shear stress.
Yes, sir. The load
But
P.
then we are saying that, let's draw the free body diagram of the hood. Let's draw the section of the hood, I mean. I'm saying that below the hood, this is what my looks like. And we are saying that something like this. So we are taking this area. At the hooden, it would be everywhere throughout the surface that we are calculating. Again, this is average. I totally agree that in this region where we have put the arrow, maybe the value of shear stress is actually quite low. That I can agree. But these are all, we are only calculating the average value, so we will take that surface. Okay?
Yes, sir.
So please, I think the double shear in pin will happen first.
Yes, sir. Steel will break by a very small margin.
It is 10.25. The wooden shear will start at 10.31. Tension in the hood is very high. I mean, the capability.
Sir, area would be pi d for double shear on pin.
Double shear. If you take half p, it is pi d square by 4. If you take p, it is 2 pi r square.
Oh, sorry, pi d square by 4. Yes.
And tension in hood will fail even if we double the load. Then only the hood is going to fail due to tension. Okay, chalo, last question of this topic. Do we have enough time? 44, I think so. In this, let's discuss that. This also will require some discussion. If force P is applied to a steel reinforcing bar as shown, which is embedded in a block of concrete, determine the smallest L for which the full normal stress in the bar can be developed. Okay, so what will happen if the L value is low? Let's try to imagine that if L is very low, what do you think will happen?
High shear.
If L is low,
Could you repeat the question? I couldn't hear
question,
it.
the question is that my presentation is visible. Yes, my PPT window.
Yes,
Yes, sir. It is visible, sir.
The question is that if I have a system like this, I have a concrete and in that a steel bar is reinforced and I apply a load P. Now two things can happen. Either my steel bar can break into two due to tension, or the reinforcement could get uprooted. These are the two things can happen. If L is very small, the tendency of uprooting will be very high. On the other
Yes,
hand,
sir.
on the other hand, as L starts approaching very big value, the rod is going to break first, but it is not going to get uprooted. Now, in this question, we have to find out the value of L so that the uprooting and the breaking happens together. That is the optimal length of L. Understood?
Yes, sir.
Yes, yes, sir. Understood.
Sir,
Hmm.
uprooting will take place at allowable bond stress or at ultimate bond stress?
Where is the ultimate point?
Means
It is allowed. I mean, the factor of safety is the same.
no, that is not my question. Means, for example, if in a machine the allowable bond stress is a particular finite value and we exceed it, so it is not necessary that the machine will break down. It will break down at ultimate bond stress. Or am I wrong?
No, no, no. In this question, we have to match the factor of safety in both the cases.
In both the cases, the factor of
Na?
safety is the same.
Yes, that is what we will have to do.
But sir, we have to determine the smallest length L for which normal stress is equal to the allowable normal stress.
No,
It
normal
is not.
We have to find out the value of the L such that the tau allowable
Full allowable normal stress. In question, it is written that we have to determine the smallest length L for which full allowable normal stress can be developed. It
Yes.
is allowable, not ultimate. So how will we proceed in that case?
Because the factor of safety is the same. We are saying that if the L is very small, then the stress in the rod will never reach the sigma allowable. If the length L is very long, then it will exceed sigma allowable. What is the length so that the normal stress is equal to sigma allowable?
Sir, normal stress does not depend on the length. It depends on diameter.
Normal stress
It depends on diameter, sir.
No,
We have to We have to
We have
do
to find out till it
different
breaks.
shear stress and for normal stress, and then we have to calculate.
We have to equate both. So
Yes.
both the quantities should be reached together. For the same value of P, I should reach tau allowable and sigma allowable at the same time. That is the minimum length of L that is allowed.
Yes, sir. Answer is coming. I have done.
The answer is coming. Did you understand? I mean, the
Sir,
student was asking the doubt.
आंसर तो आ गया सर, आंसर तो आ गया जो बोल रहे हैं, लेकिन इस स्टेटमेंट से वो कैसे पता चल रहा है कि दोनों को इक्वल करना है?
दोनों को इक्वल इसलिए करना है कि मिनिमम लेंथ है. अगर L छोटा होता तो फिर सिग्मा अलाउेबल तक हम लोग पहुंचते ही नहीं, टाउ अलाउेबल ऑलरेडी रीच हो जाता और वो ऑलरेडी टूट जाता. वी वुड नेवर बी एबल टू रीच सिग्मा अलाउेबल.
हाँ, मतलब मेरा डाउट ये है कि टाउ अलाउेबल जो है उस पे, मतलब अगर जो शियर स्ट्रेस है वो टाउ अलाउेबल को एक्सीड करेगा तब टूटेगा, या टाउ अल्टीमेट को एक्सीड करेगा तब टूटेगा?
टाउ अल्टीमेट को करेगा तब टूटेगा, बट हमारा पॉइंट ये है कि टाउ अलाउेबल से ज्यादा जाने से ये मशीन अनसेफ होने लगेगा.
ठीक है.
हमारा फैक्टर ऑफ सेफ्टी को मैच नहीं कर रहा है, वो मशीन अनसेफ होने लगेगा. और ऑब्जेक्टिव हमारा ये है कि अगर मेरा मशीन अनसेफ होगा तो वो सिग्मा अलाउेबल को एक्सीड करने के कारण अनसेफ होगा. दैट इज व्हाट आई वांट. उसके लिए मिनिमम वैल्यू ऑफ एल मेरे को चाहिए.
ओके सर, थैंक यू.
Okay, good. So this was actually a small problem sheet. We have finished 5 minutes before time. We have 4 minutes. Any questions, anything that you want to discuss?
Sir, what are the after effect of bearing stress? Like you explained, after effect of in longitudinal change is normal stress. After
Bearing
effect
stress
of
is type of a compressive stress, so there will be local compression. There are very nice examples that we can see of bearing stress. If you just Google.
In the second video, it was shown the cracks and all deformations form at the region with the bearing stress.
Bearing stress. There is a particular image that I really like. Somehow it has been removed. So this region will get deformed very badly due to bearing stress. This region which I'll put inside a box just now. This region. Can you see?
Means the pin would leave a क्या बोलते हैं इस शेप को?
सर्कल को एलिप्स बना देगा.
Yes sir, yes sir.
Okay.
So like one thing we used to do, like
exactly.
we compress on a bangle, it used to get converted into an ellipse. That is due to bearing stress.
Before that, sorry, Yogesh has sent a very nice picture. So this is what happens. This is the picture I was looking for. Due to bearing stress, this is what happened to the plate.
Yes sir.
Thank you, Yogesh. Yes, what was the question?
So when I used to compress or put pressure on the bangle from its sides, it used to get converted into an ellipse shape or an oval. So that is also due to bearing stress.
No, but you are applying the load. It is not bearing anything. Bearing stress would happen if you hold one end of the bangle with your fingers. In the bangle, you put a pencil, and from your other hand, you try to pull the pencil apart.
Yes, sir.
in your, so this year the engineering mechanics syllabus has been reduced significantly. After this, we would learn about normally stress transformation, how pressure cookers are designed, how bridges are designed, what is bending stress, what is torsion. Fortunately or unfortunately, all of that has gone. So you will just touch the topic of mechanics of solids without going into much detail. Till last year, we were actually spending a lot of time. I mean, it was half and half.
Sir, won't that affect our future studies?
So in mechanical engineering, we have changed the syllabus of mechanics of solids. So your seniors learned mechanics of solids in the 5th semester, but now you, as in your this batch mechanical, will learn mechanics of solids in the 3rd semester. We will start mechanics of solids where we have finished basic engineering mechanics, and a lot of other departments will also do the same, I would imagine, civil, aero, naval, metallurgy. So the syllabus, everybody is changing. Na? That's why it has to accommodate. It has to be accommodated like that. The students who will be badly hit due to this, or potentially badly hit due to this change in syllabus, are what are known as the circuit branches. They will never learn about stress transformation now. Okay, I'm stopping the